In this video, we're going to mesh for CFD, so we'll use the mesh object. Structural meshes use mechanical, and we want to just open that geometry we finished editing in SpaceClaim and apply a few settings, then attach a Fluent model to that. Okay, here's our geometry. We're going to create some named selections, which means I can just pick a face, hit the N key, and say inlet. Pick that, N key, outlet, and then select all the faces, and that might be all the bodies. So with the face filter, select all the faces and then Control, unselect the inlet and outlet, type the N key and say walls. So there's our walls that we want to have for doing inflation. And the non-body is, let's rename that and say fluid. So that's all the name selections. What we want to do is with mesh, we want to tell it this is for CFD. Maybe 0.025 is a good element size. If you look at the size of the ruler, it's fairly coarse still, but this is a quick demo. And then on inflation, this is where we want inflation on the faces in the name selection called walls, and we want to tell it to use some first layer thickness that maybe a fluids guy would calculate the proper thing for turbulent boundary layer, the Y plus value or something. I'm just going to make up a number because I haven't done that work. And yep, let's see how that looks when we generate a mesh. I think I put one too many zeros in there. Let's go point. There we go, and hit generate mesh. That's better. And so we can see that we have inflation layers around the inlet and around the outlet. Maybe not perfect, but probably out here it's a long way from where most of the flow will be coming out. So I can tolerate maybe a little loss there. I'm not going to fuss about that. And if we do a quick section plane through here, we can check that we've got inflation layers where we want them interior to the body. So yeah, we're getting the inflation we wanted. So I'm happy with that. And the next thing is to send this mesh over to Fluent. So we'll close mesh, drag out Fluent, and update. So the mesh is updated. I'll launch Fluent, and we'll get some double precision, solve on 4 cores, and start up. Okay, Fluent has launched. We're going with steady flow, and we're going with turbulent model. So the default boundary condition is going to be inlet velocity. I'm going to start with that, and I don't really know the physics of the problem. I'm just doing a little demo here, so I'll just put in 1 meter per second initially, and we will take a quick look at this, and it'll be as simple as maybe we want a report definition to get the area weighted average pressure at the inlet. So static pressure at the inlet to push that 1 meter per second of air through the model. So we'll say OK to that. And we want to initialize, and we'll just go initialize with hybrid. And we want maybe some graphics, like some path lines, and we'll get some path lines from the inlet, and they'll be ready when we get some. Let's see if we can spin that around a bit. There's the inlet, down, up, and out. There we go. So close that up. We'll hit up the calculation, and let's just give it 500 iterations and calculate. And here's the pressure being calculated for us, and here's the residuals, and we want to see those residuals dropping. I didn't update any defaults, so I think 1 e to the minus 2 is the 0.001. 1 e to the minus 3 is the default monitor for the solution. And we'll come back in a little while. Looks like the pressure is converging to some steady state pressure. And the calculation is complete. And let's see, I guess the residuals came down somewhat. And there's our pressure input. Maybe we want to initialize with a much higher pressure and see what we get. But the path lines seem to show the flow going into the inlet through those the four-way, through the bottom, up through the four to the outlet, going pretty much straight out the big opening at the top. Yeah, so under inlet, we might want a pressure inlet, and instead of 45, will be try 4,000, and instead of measuring the pressure as a report, we will get a new surface report at the inlet for area weighted average velocity. And at the inlet, I don't know what axis it is, but magnitude's fine. And currently that's 1 meter per second, which was my original input. But with this huge pressure, it'll be a very different number. So we'll just say OK to that. We'll apply that inlet pressure, and we'll go ahead and calculate and say OK, and see what happens to our residuals. Here's our velocity, searching for a solution, and the residuals started up here, and we'll see where they come down to. Looks like somewhere around 20 meters per second of inlet velocity average. So I think I'm just going to let the next video be the video to show some results. So we'll don't need to see that now, and I'll upload the video for viewing.